everyone. Sorry about the 5-minute delay. I was running late this morning. I'm just gonna say Murphy's Law says that anything that can go wrong will go wrong. But I'm here now, so we have 45 minutes to go over today's topic. I'm substituting for Gerald. He's currently in India. He flew back shortly after last week's lecture. And what we're going to be discussing today is the relationship between C and C++. What we've been doing so far is we've only been talking about C++, and most C code actually compiles in C++. C++ is just a superset of C. At the same time though, there are some reasons, or there are some cases where you might want to use pure C, the original C, as opposed to C++ with all the extensions that it added. And we'll go through some code today and take a look at when that would be the case. Before we get started coding, just a couple of announcements. A6 is due today at midnight at 11:59 p.m. If you haven't started it yet, then I urge you to at least do part of it, because we gave you a lot of the starter code already in the last two lectures. So you can at least get partial credit even if you submit something based off of just that. Also related to A6, I made a couple of changes to the testing script last night. If you've been following all the instructions in the spec for A6, then don't worry, you're almost certainly fine. But just run that again before you submit. Code for the last lecture is up. I wasn't able to get the video up. For some reason, uploads are really slow on my computer, but I'll get that up as soon as I can. If you want, the code is still there, so that you can refer to that for your assignment. I'll grade A5 and A6 soon, in the next couple of days. We're only going to have a few days for regrades for those, because we need to get grades in as soon as possible. So then just keep an eye open for that. Related to those grades, once we have all the grades together, what I'm going to do is I'm going to create a document and drop it into your handed directory. That document will have all of your grades for all the previous assignments that we'll be using for grading. So again, once those are ready, please take a look at those and please let us know if you made any errors, because we need to fix those really quickly if there are any. For the project, that's due next week. Ideally, right now, we should have something that compiles and runs. It should be at least a bare minimum, so that in the next week or so, if you have time, then you can build on that, and then you can submit it. If you have any questions about grading or logistics, then email Gerald. I'm not going to be grading the project. It's going to be him, and he also has the last word about grades. So if you're concerned about your grade, or if you're concerned about how the project will be graded, then please email him. He is replying about once every day or once every 2 days. He's a little bit disconnected from internet, which has been kind of difficult for me too. I kind of prepared this lecture all on my own. If you have concerns about how your code is running, if you want help debugging an error, then of course I'll still be available during office hours today and tomorrow. And if you set up an appointment with me sufficiently far in advance, then I might be able to make a little bit of time next week too. I'm flying out on Wednesday, so then I'm only available on Monday and Tuesday by appointment, possibly. Okay, I think that's it for announcements. Let's get started. Make an lecture 14 directory, and I have a directory with a little bit of code that I already wrote. I'm going to copy one file from there into L14. Here we go. So this is in C++ code. I think all of you know enough about C++ that I don't need to write this interactively. What I'm just going to do is I'm going to step through this code, and we'll see what it does. And then we'll think about how we can write the equivalent code in C. Here we go. I wrote a file called primes.cpp. Basically what this does is it prompts the user to enter a number, and then after that they can enter more numbers, and it will print whether those numbers are prime or composite. Let's start at the bottom actually, let's go down to the main. So here's our main function. I wrote a function called readInt, which we'll take a look at in a second. The read function just takes in a prompt message, prints that out, and then reads anything from the screen, or from the console that the user enters. And using that integer value, we call this other function construct primes. This populates a vector of integers that contains all the prime numbers from 2, 3, 5, 7, all the way up to the max int that we specify, including the max int. And then, inside a loop, what we're going to say is that we're going to call a readInt function repeatedly. If the number that we read in is prime, then we'll print out that it's prime. Otherwise, we'll print out that it's not prime. And we're making the assumption that each number n that we read in is less than or equal to the maximum that was specified already. The helper functions that we wrote up here are readInt. So we basically just say, okay, using cout, print out the prompt, and we'll get an input. Using that input, which is a string, we're going to convert it to an integer. We've already seen this in previous assignments. This is basically the way it works. You create a string stream object. You push your input into there, and then you take an int, and you get your int using your string stream object. I added a little bit of extra code here. This is basically just saying, if the user entered stuff that wasn't an integer, then that means after we read the integer value from the stream, there's still going to be something left over. And this is just checking for that. If we are not at the EOF for the stream, EOF means end of file, then we say, we get that extra value that was entered, and I don't even use it, I guess. I changed my code a while ago. But we can print out that error message if we wanted to. Instead, what we're doing is, we're just throwing an exception. We're saying invalid argument could not parse input. We also check if the number is less than 0. If the number that we inputted is less than 0, then we say the input is negative, which we don't really want because, I don't think anyone would ever really want to see if, for example, -5 is prime, because it's not. And then we return that number that we read in, which brings us back down here. The next helper function is this one, construct primes. I'm going to scroll up to the top. Okay, here's our construct primes. So this is the method that populates our vector. We say for all the numbers from 2 up to n, including the argument n, we're going to create a flag value, which is initially true. And we're going to try dividing our number I, the value inside the average for loop, by every value inside the vector. If the remainder is ever 0 for any of those, then we set our flag to false. So essentially now our flag is true if the number is prime, and false if the number I is not prime. And then down here we can check the flag value. If our flag is true, then we say prime, so that push back I. And since we're doing this for all values from 2 up to n, this will populate primes with 2, 3, 5, 7, 11, and so on, until n. Okay, so that was the second function. I'm going to go back down here. I wrote one more function called isPrime, which just takes a number n, and then it uses that global vector to determine whether the number n is prime or not. What that looks like is this one line. I use the algorithms library. There's a method called std::find. And this takes 2 arguments. It takes a begin iterator, or 3 arguments, sorry. It takes a begin iterator, an end iterator, and a value that we're searching for. If it finds a value anywhere between those 2 iterator positions, then it'll return the position of that value we compare it to this thing, primes.end, we see that it's false. So we say, oh, this number is, wait, if we get the number n, yeah, so if it exists inside the element, or inside the vector, yeah, that's right. If n exists inside the vector, then this thing returns a value which is not equal to primes.n, and we return true. If our number n cannot be found anywhere inside the vector between those two iterators, then we return this thing, primes.n. And they're equal, so this method returns false, and that's the behavior that we want. So that's pretty much how that method works. And these are just some the relevant import statements that we need. So that's our C++. I'm going to put that here. I'm just going to try compiling it. And let's run it. Let's try entering a maximum integer value of 50. Now we'll try numbers that are less than this. Like just basic cases, 0 and 1 are both not prime. 2 is prime, that looks correct. 3 is also prime. Let's try 4. We expect this to be not prime. Yeah. And we can just keep trying all these different numbers, and it seems to be working correctly. We can try larger numbers too. And everything seems to be correct. Just to make sure this gives us some appropriate behavior when we enter an invalid value. Let's try entering some number, and then we just have some jump value at the end. So we already saw that we're going to throw an exception, and this is what happened. This is what the message looks like. I'm just going to run it one more time. If the first value that we enter is also some garbage value, then we get kind of the same error. If we ever enter something that's negative, then it gives us a message input is negative, and it also raises an exception. So this looks good. Let's take our code that we wrote and try converting it into C. All C files are written with an extension .c. I'm just going to show the original code side by side. This is going to be primes.c. So I'll get back to the import statements. I'll try to raise the whole main. Here we go. This is pretty much the bare minimum you can have for a C program. And I'm just going to skip compiling it because it seems correct so far. Let's see, what do we need? I'm going to go to the file on the left again and scroll all the way down to the bottom. We'll start with the main function. Let's say we just declare int maxage. We'll just give it some value to begin with. We're going to have to call construct primes. And I'll get back to that later. Okay, let's write the structure of this loop. If it's n, if it is prime, then we do something here. Let's say else. Okay, so we have an outline of our code right now. Assuming we have a method called isPrime. So let's say we have bool isPrime. It takes an int. And for now, we're just going to return true. Okay. What we have right now should compile. We're not doing anything too complicated. Let's just make sure. When we're using C, we usually compile for the C99 standard. And the name of the file is times.c. So let's see what happens here. Okay, we have a couple of errors. So it's basically saying unknown type bool, unknown type true. And even with this small piece of code, we've already seen a difference between C and C++. In C, there is actually no Boolean type. The closest equivalent is int, and that's what we have to use. So instead of returning bool, we're going to return int. So, yeah?
You could also include stdbool.h.
That is true, but I'm not going to do that. That is perfectly valid. But I think it really depends on which.
It does a type def to int, and
Yeah.
it uses true equals 1 and false is 0 anyway. But
Yeah, so depending on what kind of code base you're working in, if you're working on a large C project. In some cases, you might actually see a library that actually defines a Boolean value using a type def statement. But in some other projects, you might see them using int rather than bool. So these are both perfectly valid. The one that I personally prefer is just to use int. So we're going to go with that. Let's return 1. So 1 is the equivalent of true, and 0 is the equivalent of false. Okay, that should fix the errors we had before. So that should fix that. Let's try it. Okay, I forgot one true. So this one should also be changed to 1. Let's try compiling now. Okay, it compiles. If we run it, we'll probably just get an infinite loop. Yeah, we're inside an infinite loop. The while loop is just running forever. I'm going to control C. Okay, now let's take our other file again. Here's our C++ code on the left, our C code on the right. What else do we want to write? Let's go down to the bottom again. And we have a couple of functions that read in integers and also print out output. Right now, we're kind of just giving the integers default values. We'll change that a little bit later. And let's just try seeing how we print out messages. The equivalent to cout in pure C is called printf. It's a function. And we want a message like, so we want to say something is prime, in this case. We actually have to say the new line. We have to say that explicitly, /n means new line character. Okay, this is the start. We want to print out the value itself. And this actually just looks completely different from cout. We're going to say, here's our value, %d. Percent means there's going to be a value that's going to get printed. And d tells printf, read this value as a signed integer. The argument is going to go right here. This is how we pass it in. And that's basically how you use printf. At least to print out an integer. It's kind of strange. It's very different from cout. This is why C++ added cout to begin with. Because remembering that %d, for example, corresponds to an integer value, as opposed to, let's say, %s, which means a string. I think %l means a long int, and there are a bunch of these other format specifiers. That's what they're called. Just memorizing all these format specifiers is a bit of a pain. So personally, I kind of prefer cout, but at the same time, the C way of doing it has its benefits. And let's do the same thing for the other message down here. So %d sub integer is not a prime. We pass in that integer. And that should work. Okay, well if we try compiling and running this, we'll get an even longer infinite loop now with a bunch of output getting printed. So let's try to break that. Let's try to end the infinite loop. We should actually be reading in values. Let's see, up here, here's our function read in. So let's write that. Let's write something similar to that. Okay. Right now we're running into a second issue, or this is not the second issue. We're running into another issue with C as opposed to C++. So in C, there is no string type. Actually, in general, there are no classes defined in C. There's no notion of classes. This means we have to use the nearest equivalent, which we know from C++ is char pointer. And in fact, we'll just make it const char pointer because it's not supposed to get changed at all. Let's try printing stuff out. If you want to print out a C-style string, char star, the format specifier is called %s. We want to print that. This is going to be the prompt. We don't want a new line at the end, so we don't say the /n. Here is our prompt. We print that. Then we have to read in an integer. Or we'll read in a string actually, then we'll convert it into an integer. Kind of the same thing that we did for the C++ code. So we're going to read in a string. We have to read it into a variable. Let's just call that input. And we have to create the input. So again, we don't have a string type. We have to actually create a char star. Char star is the same thing as a char array. And in this case, there's actually a distinction. If we're creating a variable of type char star, and we'll call that input. Let's say we did this. This code over here is wrong. It's not going to work. Or it'll compile possibly, but it's going to give us an error at runtime. And the reason for that is because input is a char pointer, but it's a pointer to just a single character, which means if we read in a bunch of characters, we're just going to overflow that point. And yeah, we want to store more than just one character. So the way to do that is instead of creating a pointer to a char, we're going to create a character array with a specified size. I'm just going to go with 16. Powers of 2 are kind of nice. This means input is a pointer to a character. It's not extremely clear from this, but it is a pointer to a character. And there can be 16 different characters in that memory location. Does that make sense? Yes? No? Probably no. Basically, in C, when you're dealing with arrays are very similar to pointers. They're actually almost interchangeable. It's kind of true in C++ too. Like for example, when you're working on your A6, there is a type T star elem, right? And that's actually, inside your A6 code, you're going to be saying elem equals, and then you're going to be allocating some memory on the heap for, let's say, 4 different elements of size T. You'll be allocating that on the heap using the new operator. So in A6, elem is a pointer to an array, and all of those arrays take or store elements of type T. This is a little bit similar here. We have input, and we're not using the new operator. The array is going to be located on the stack. But we can essentially treat input as if it was a pointer, which is very important in this line. %s means input better be a pointer to a character. Okay. So at this point, we're kind of just waiting for an input. And let's just return some dummy value here. We can start calling the function right now. Our prompt was enter the maximum integer must be positive. That's our prompt message. I'm just going to pass that into the function that we wrote. We should be calling it down here too. If you go back to the C++ version of our code, inside the loop, the first line is int n equals read int, and we have a string. So instead of int n equals 2, we're going to say read int, enter a positive integer. There we go. Let's try compiling or saving this and put in. We'll put it in the C++ version 2. And we'll run that command, gcc, using the C99 standard for our C file. Okay, there are some warnings. These warnings are basically happening because we skipped the import statements earlier. Let's just add those. I'm not going to read these, they're not very interesting. At the top, we basically just have to say, have to include, there are a couple of libraries. The ones that you're going to be using in most of your code are stdio.h and stdlib.h. Save that and quit. Try compiling again. The connection to the lab machines is very slow and causing me a lot of sadness over the last few days. Okay, let's run this. This doesn't have everything we want, but it's a pretty good start. Enter the maximum integer. We just returned a dummy value. It doesn't even matter what we enter. The dummy value was 2. Enter a positive integer. And it says 2 is prime. Now it's asking for a different number. It's saying 1, and it's saying 2 is prime because it didn't read our integer value that we entered. So we can do this for anything. I think we should even be able to do negative numbers and it doesn't crash. If we enter something that can't be parsed to an integer, then even that seems to work just fine, which is kind of weird. So I'm going to control C out of this code. And let's start adding some more functionality. Here's primes.c. I'm going to split the screen again for primes.cpp on our left. And let's go down. Here's the read-in function again from the C++ code. Okay, what should we do next? Okay, let's take our, what we should do next is we should take our input and convert it to an integer. This is going to be very different from the C++ code. It's actually going to be a lot more concise, at least for now. There's a function inside C called a2i, which takes in a string, let's pass in our C string input, and it returns an integer. So we'll do that. And we can just return that value. We're not doing any error checking or anything. A2i just simply assumes that the value can be converted correctly. And assuming that it does, we can return that value. So if we take that code, save and quit, okay. Let's try entering some numbers. Okay, it's actually taking our input now, yeah.
When should we substitute C code for C++?
All these C equivalents that I'm talking about right now, you should pretty much never use them in C++. And that's why a lot of this code probably looks really unfamiliar. So when you're coding in C++, you should use the C++ idioms. Like, you don't use a2i, you use string stream. You don't use printf, you use cout. Stuff like that. If you're coding in pure C, then obviously all those C++ features just don't exist, and then you have to use the C idioms like printf and h to I, and stuff like that. Yeah, so C++ is a superset of the C programming language. Any C, or almost all C code does compile into C++. But you should avoid writing C code in C++ whenever you can. Does that answer your question?
And you can see C code faster than C++ code.
There isn't a really clear answer to that. The question was, is C code faster than C++ code? In some cases, yes. In some cases, no. It kind of depends on your application, on your compiler, also on your operating system. So if you're very concerned about performance, well, first of all, in general, C and C++ will have kind of similar performance. They're both very fast. Compared to other languages like Java and Python, they're much faster than those. So if you're concerned about performance, you can use either C or C++. If you want to choose between those two, then you have to consider some other factors in mind, like code maintainability, which is usually a bit easier in C++ than in C. You might be able to write some micro benchmarks that check whether the C version of something or the C++ version of something will be faster, and using that you can determine which language you'd rather use. But in general, it's pretty difficult to make that decision.
And how's the compatibility with C# for C and C++?
C# is a different programming language. I don't actually know C#. I believe it's a superset of C++. So all C code runs in C++, or most C code runs in C++, then most C++ code runs in C#. At least that was true a while ago. Then C++ 11 happened, and then it's just probably not true anymore. But yeah, C# is also a different programming language. Okay, let's go that way. But yeah, if you run this code, you can see that it's actually reading in the numbers here. But it doesn't have error handling. So we'll keep that in mind. Let's at least get some of the prime number checking code to work first, and then maybe we'll add error handling if we have time. Okay, we got rid of these two, so I'm going to delete both of those lines. So right here, we're going to say to do error handling. And up here too, it might be relevant. But at least we have a basic outline for this function readInt. Let's move on to construct primes. Once we have construct primes, then we should be able to do isPrime. So this is also something that we have to do. This is just a stub right now, doesn't really mean anything. Construct primes. It's going to take an integer n. And we're going to be updating the equivalent of a vector in C++. If we look at our C++ code again, zoom it loads. Here it is. If we look at our C++ code, we see that we have a global vector that we created. I made this global just for simplicity. Here's our vector of int. And then we just do operations on that in construct primes and then also inside isPrime. There are no classes in C, which means we have to use the next closest equivalent vector. In this case, we're back to arrays again. So let's do that. So instead of having a vector of int, we're going to be creating an array of int. We want this array to be on the heap. We're going to be, like in C++, the way we create something on the heap is using the new operator. So this is going to be a pointer. It's going to point to something on the heap pretty soon, a bunch of prime numbers. But for now, it's just a pointer. It doesn't have an array. We don't know what it's not an array. We don't really know what its size is going to be, at least not yet. The reason I'm making it a pointer to something on the heap, rather than a fixed size array on the stack, is because if we give it a fixed size, let's say we give it a fixed size of 4, that means it can store the prime numbers 2, 3, 5, and 7. But what if we want to store primes that are larger than that? Like what if the maximum integer that we enter is 11? And 11 is a prime number, but we want to store it inside our array. So this is the problem with arrays. And this is why C++ even added vectors. C++ added vectors rather than arrays because the size of an array is fixed. You can't increase it at runtime. If you say it's going to have 4 elements, then it's always going to have 4 elements. The way to get around that is to make it a pointer and make that pointer point to something on the heap. So we'll do that. We don't, unfortunately, C-style arrays don't actually know what their own length and capacity are. So we'll have to create those ourselves. I'll put it up here. Int primes cap. We're not going to initialize these just yet. We'll do that inside construct primes. So when construct primes is called, we say primes len equals 0. We have no prime numbers so far. We're going to create them soon enough. Let's say our capacity is 4. And let's allocate some space for our primes. It's going to be of type int star. We're going to be calling a function. And we're going to have to put an argument inside here. The function malloc is the C equivalent of new in C++. Malloc means I'm going to set aside some space on the heap. And then I'm going to return a pointer to that. The pointer actually has to be casted to the correct type of pointer, which is int star. Well, it doesn't have to be, but that's good practice. So we're doing that. The argument now is going to be the number of bytes that we want. So what's that going to be? The size of an int is 4. This is 4 bytes, generally. So we're going to say 4 times the capacity. So this works. A better way to write it, instead of saying 4, is to say size of int. This is an operator that you can use. And this sets aside the desired amount of memory in bytes on the heap. And it sets primes to point to that location. We can't use iterators to create our for loop, like on the left-hand side, because there aren't really iterators in C. So we just write a for loop just like this, using an iterator variable I as the index. And we'll fill that in soon. Okay. For now, let's see if our code compiles. I'm going to save input from that file, and I'll close the C++ file too. Okay, looks like it worked. So when you try to enter the values, it's not really working correctly, but at least we compiled. Okay, what's next? Let's fill in this loop, and then we can go on to its prime. Okay. Leave that there actually. Let's go back to the C++ file. What we did was we created a Boolean flag. Let's do the same thing here. There's no Boolean type again. So we're going to say int flag equals, instead of true, we'll use 1. Let's do that. And we have a second for loop. So we can't use our iterator code. We'll just say j equals 0. J is less than primes len. J plus plus. So we're going to be looping over every index inside our primes. Inside our primes array, because we can't use the iterator version. So let's say if I'm just translating the code on the left-hand side. If I mod .everything.rt, we're using the element inside primes at index j. If that thing is equal to 0, then we set our flag to 0 rather than false, and we break. Let's close that. If our flag value is true, then we say primes. We can't say primes up and back, actually. Primes at primes len. is equal to that value that we were looking at, I. And we increase the length by 1. So this adds a value to the array, assuming it doesn't overflow the end of the array. So I'll leave it to do up here again. But what we have right now should work for some cases without crashing. Okay, if we enter a sufficiently small maximum number, then our code will work. Let's say 5. It's still saying all these are primes because we don't have a raise prime function yet, or whatever, that's fine. We put out of there. And we have a couple of to-dos now. So if we overflow the capacity, we got to essentially reallocate everything inside our primes array. The way we check for that is if the length is equal to the capacity. So what we do in this case is we call a method called realloc, which is very similar to malloc. It's going to take the stuff that we allocated before and move it to a new location with the specified size. We have to do this weird cast again, and then we call realloc. We'll pass the argument in a second, and we'll say we double the capacity. Okay, let's go back up here. The argument is going to be 2 things. First of all, the original pointer, which could possibly get moved now. If it gets moved, it's going to get returned and reassigned. And now we have to say, how much space do we want? So again, we'll have a size of int term. What's the number of bits? It's going to be times cap times 2 to say that we double the capacity. There we go. I'm going to save and quit. Our construct function should be done. We still have to do is prime, but hopefully this will run without crashing. Okay, nothing crashed yet. What if we enter a very large number? Okay, still didn't seem to crash. Okay. Now inside is prime. Let's see. Since we have a vector of primes and we have a number n, which is hopefully less than or equal to the maximum element in that vector, we can just check everything inside it and see if any of them are equal to n. If anything is equal, then we know we found a prime number. Yeah, so we can't do this in one line, the same way we did with the C++ code. There's no algorithm library with an std find function that we can call. So we kind of have to do this ourselves. So we basically just search everything inside that array. If anything is equal to the value we're looking for, then we say good, we found it. And we return 1. Otherwise, if we fall through to this line, we just return 0. And again, this is representing under true or false. Okay, this should be good. Enter the maximum integer value. Okay, let's try what we can. 0, 1 are not prime, 2 is apparently not prime, that's a problem. Okay, I made a mistake somewhere. That's fine. This prime looks fine. What's going on up here? Times n equals 0, times cap is 4, that's fine. think everything here is okay. I'm not quite sure what I'm missing. We're reading now. Yeah. No, I set it to 1 and 0. So I think the flag is fine. The thing is, I just didn't call construct prime. This is a little bit sad. The construct prime was maxed. I totally forgot about that. Read it doesn't have error handling, but whatever. For now. While run 15. 2 is prime good. 1 and 0 goes on. Okay, everything seems to be working correctly. Up till the maximum integer that we said we never specified. Here we go. Alright. I was kind of hoping I could get a little bit further. I had a little bit more code that I would have liked to go over. What I'll do is I'll put that code online because it's already 12:55. But what we showed right now is basically just an overview of C. Kind of seeing some of the differences between C and C++. So I guess just to summarize, the biggest differences are you don't really have classes in C. So that removes stuff like string, vector, and you have to use a bunch of C-style equivalents. Instead of using cout, that's also an instance of a class. So instead of using that, you're going to be using printf. Instead of using cin, you're going to be using scanf. And you have to be very careful when you're allocating memory. You have to worry about it much more in C than you would in C++. I think those are the basic differences. Yeah, I'll upload some more code later on if you want to take a look at that. I guess for the time being, good luck with A6, good luck with your project, and yeah, if you have any concerns, let me and Daryl know. Thanks.